Okay, so today we're just going to review some of our rules whenever we're dealing with simplifying polynomials. Okay, polynomials is just a fancy word for an expression that has variables that are both positive and whole numbers. Okay, so we're going to be simplifying polynomials. So, excuse me. So whenever we are adding and subtracting polynomials, we are pretty much just combining like terms, okay? So we always want to remind ourselves that we are not going to change the variables and the exponents. All we have to do is add or subtract the coefficients. So for example, if I have 9x squared y minus 10x squared y, okay, all we do is subtract the coefficients, 9 minus 10, that's going to give me -1, while the variables and exponents stay the same. Okay, now algebraically, this would be written as -x squared y, right? Because I don't write unnecessary things, okay? So if I have one of something, I don't tell you that, okay? You just have to understand it. Another example, if you subtract 6w from 8w, that means you have 8 w's and you're going to take away 6 w's. Okay, you don't just have 2 left, you have 2 w's left, okay? So 2w. So just some examples of combining those like terms. So hopefully you guys are very comfortable with these. Like I said, I just want to use this page as a reference for you to kind of go back to if you ever kind of, you know, need a reference point. So when we have polynomials that we're multiplying together, if you have a monomial times a monomial is just meaning that they are one term. Okay. All we have to do, the product rule will tell me that if the bases are the same, okay, if the bases are the same, what do we do to the exponents? Add exponents. Okay, so in algebra, or we use variables for a couple different reasons. Most of the time they're because we're trying to solve a problem for something that we don't know yet, right? A value that we don't know. We also use it as a way to show you that a value can vary. It doesn't have to be the same. And then we also use it in a general sense. Whenever I'm trying to explain a rule to you, but I don't want to make it unique by using numbers, I just want to generalize it. So I just use letters like this A and this B here. I don't know what the A and B are. They can be any numbers. So I know that no matter what they are, if I have my bases the same, I just add them together. Okay. So h squared times h to the 6, h to the 2 plus 6 is 8. So h to the 8. Okay. So whenever stuff gets a little bit more complicated, let's make sure that we're comfortable with it. When I'm multiplying a monomial times a monomial, okay, I always multiply the coefficients and add the exponents, okay? Usually the coefficients, you do exactly what they say. Like we're multiplying here. So I'm gonna take -2 times 7 is -14. And then I'm gonna add the exponents that have like bases. So I have an a squared here and an a cubed there. So I have 5a's, a to the 5th. And then I have a b times a b. Now, once again, just like whenever a coefficient has a number 1, we don't write it. That's the same with exponents. This b has an exponent, okay? The exponent is a 1, b to the first power. I just won't write it because it's not necessary and it takes more time. So filling those in while you're simplifying can help you because the rules say add the exponents. So if you don't see the exponents, what do? You know that they're the number 1. So b to the first times b to the first is b to the second. Okay, let's go for the power rule. When I have a monomial that's being raised to a power, okay, a monomial that's being raised to the power, I'm going to multiply the exponents together. So a to the, or x to the a raised to the b is the same as saying a x to the a times b. Okay, so whenever you have a power raised to a power, you multiply the exponents. So here, x squared to the cube is x to the 6th. Okay, when you have a monomial being raised to a power, okay, monomial just means there's one term, meaning that there's no plus signs, okay? Remember, a term is separated with plus signs and minus signs. So I don't have multiple terms in here, I only have one term. When you have a monomial that's being raised to a power, so this whole thing is being raised to the power of 2, I get to raise each factor inside of my monomial to that square, okay? So factors are the pieces that make up your multiplication problem. So I have -2 times m to the 5th. So I'm going to take this squared to both the -2 and to the m to the 5th. So -2 squared, -2 times -2 is a +4. And then m to the 5th squared, you multiply m to the 10th. Okay, and then we still have our m cubed. So a lot of times when we're simplifying, I'm not just giving you one, or you're not just gonna have to use one rule. You might have to use a lot of them. I first took care of that exponent that could be distributed to each one of my factors. And now I'm gonna take care of this multiplying. So m to the 10th times m to the 3rd, I have 4, and I have to add those. Remember this rule up here? To the 13th. Okay, quotient rule. 8 x to the a divided by x to the b. I am going to subtract those, a minus b. And these are all, I call them rules, but they're really just for your convenience. We could work them out in a way that, you know, hopefully when you went to pre-algebra, you saw why these rules exist and how they work, okay? If you don't understand why do I multiply, come talk to me and we'll work it out, okay? Okay, so I need to subtract. So the first thing, I'm looking at these guys. I've got a coefficient divided by, I've got coefficients and I have my variables. So a couple things you always do want to make sure is that when you're dealing with coefficients in a rational expression, meaning that you've got variables in the top and the bottom, you do want to make sure it's simplified. 27 over 42. I can't simplify that anymore. So I'm still going to have 27 divided by 42. But I'm going to have x to the 5th divided by x. Remember that has a 1. So 5 minus 4 is 5 minus 1 is just going to be x to the 4th. Now I'm still going to have my 27 and my 42. Okay, there's nothing I can, or can I? Well, no, I can't actually, sorry. 27 and 42. Can I simplify 27 and 42? I can divide a 3 out of both of those. So I have 9 divided by, what's that going to give me, 14? Yeah, 9/14. So you do always want to make sure you perform any of the division or simplifying that's whenever with those coefficients, okay? All right, once again, we got another one. Now, we're still going to use our order of operations that you learned back in pre-algebra, okay? So like here, I have a term being raised to a power, and then I'm also having it divided. What do you do first? Do you take care of this power, or do you do your division? Well, please excuse my dear Aunt Sally, please excuse exponents. So you want to take care of any exponents that can be simplified first. That guy needs to be simplified. So I have y squared raised to the squared is y to the 4th. Y to the 4th divided by y to the 4th. So I can use this rule, right, where I'm going to subtract. What do I end up with? 4 minus 4, that equals y to the 0 power. What is y to the 0 power? We're actually about to cover that here in a second. So think about this. If you have the same number on the top and the bottom and you divide, like what's 5 divided by 5? 1. What's 12 divided by 12? 1. What's a million divided by a million? 1. It's always going to equal 1. Okay? So you're getting a little bit of seeing that in both ways. All right, negative exponents. How do you deal with negative exponents? A negative exponent relates to a positive exponent like this. Okay, there's a relationship between negative exponents and positive exponents, and it's the reciprocal of it. Okay, so all you have to do is put it onto the bottom of a fraction. You can kind of think. Okay. All right, like here, I've got -5 x to the -2. Now be careful, this -5 isn't being affected by the -2, right? The -5 The -2 is just for the x. It's directly above the x. So my -5 still stays where it's at. But if I want to turn my negative exponent positive, which that is, you always want to make sure your exponents are positive. I didn't mention that, but it's not proper to leave them with negative exponents. You have to write them on the bottom of your fraction. If you don't have a fraction yet, put a line under it and make a fraction. Okay. Here, I don't see any negatives, right? But I do have some division I can simplify here. 4/8, that's the same thing as saying 1/2, right? I'm gonna divide 4 out of both of those. And then I have k squared divided by k to the 5th. That leaves me with, you can think of it as k to the -3rd, right? Because 2 minus 5 is -3. So you can take it a couple different steps, but now you have to make it into a positive one. So 1 over 2k to the 3rd. Okay, you always want to make sure that they're proper. I like to avoid any negatives to start with, and whenever I cancel these out, k to the 2nd divided by k to the 5th, I know there's going to be 3 extra factors of k on the bottom, so I don't even make it negative. But I wanted to show you it so that you saw how the negatives work. But we'll see some more of those. Here, x to the w, anything raised, I'm sorry, x to the 0, anything raised to the 0 power is 1. I don't care what it is. If it's a million raised to the 0 power, it's still 1. Okay? 7 times x to the 0 power. Be careful, this isn't just 1, right? This 7 is not being affected by this exponent. The exponent is directly above the x, so the x is the only thing. So I still have 7 times what's x to the 0 power. It's just 1, so my answer is 7. Okay, here I have a whole expression I need to simplify. I'm going to first go ahead and multiply those exponents. So 4 times 2 is 8, divided by w to the 8. Okay, just like before, 8 minus 8 is w to the 0 power, which is 1. Okay, so some of this over here, probably a review for you. Okay, maybe some of these got a little bit more complicated, and some of us might have remembered some of those more complicated expressions that you simplified. But anyway, we'll make sure that we review and dive into some really fun ones. So I'll see you in the next video.